Good morning, geometry students. Happy Wednesday. Same as usual. Today's Flipgrid is at that link. It's an interesting question today. Check it out. I would love to hear your answers. You have already found the YouTube lesson for today. Now, I would like you to pause this video and try this problem in your notes for me. And then unpause it, and we will do it together. But we obviously need more space than this, so I have created another slide for us. Alright, this problem says, planes that fly at high speeds and low elevations have radar systems that can determine the range of an obstacle and the angle of elevation to the top of the obstacle. The radar of a plane flying at an altitude of 20,000 feet detects a tower that is 25,000 feet away with an angle of 1 degree of elevation. So the first part of the question is, how many feet must the plane rise to pass over the tower? And that's the H there that they're asking for. And part B says, planes cannot come closer than 1,000 feet vertically to any object. At what altitude must the plane fly in order to pass over the tower? Okay, so the second part says that we have to be, that we have to be another 1,000 feet. That the plane, this is a plane, this is an airplane. Don't ask me what that last part was. That was supposed to be a little, like, never mind, it's a plane, but the plane needs to be 1,000 feet above that tower anyways. So that's for part B. Okay, yeah, let's just get rid of that so you can't make fun of me for it. Okay. Alright, so I'm gonna redraw this triangle right here. Very, very long and skinny. So we don't know what this is. This is what we want to figure out. We know that this is 1 degree. And we know that the tower is 25,000 feet away with an angle of 1 degree of elevation. Beautiful, beautiful. Okay, so let's... First thing I'm always going to do is mark my diagram. Hopefully you've seen that theme throughout this year that Mrs. Dodge will tell you. Make a diagram, mark it, love it, use it. Yes. So if this is the angle that I'm looking at, that makes this the opposite. This is the adjacent, and of course, my hypotenuse is always opposite the 90-degree angle. So which trig function do I need to use for this problem? Let's see, I have the opposite, I have the hypotenuse. This is, let me think. So, TOA. I need opposite and hypotenuse. Oh, bing, 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 bing. Winner. Winner. We are going to use sine, because that's the one that uses the opposite and the hypotenuse. Beautiful, beautiful. So, yeah, let's go back to our original color. So, sine of 1 degree is equal to opposite over hypotenuse. And now, who remembers how to get h by itself? Yes, indeed. We need to multiply by 25,000 on both sides. And I don't know what that is in my head, so I'm going to come over here to my handy-dandy calculator and do 25,000 times sine of 1 degree. And we get, let's go back to this color. We get 436.3 approximately. So that is how many feet the plane needs to rise to pass over the tower. And then what part B is asking is just we need 1,000 more feet. We need 1,000 feet more than that. So if I just take that and I add, I'm just gonna take this plus 1,000, I will get, for part B, 1,436.3 feet. And there you are. There you have it. So, next time you're flying your plane, make sure that you do your math before you go crashing into any cell phone towers or whatever. Radar tower. No, I don't know. It just is a tower. That's okay. Alrighty. Thanks for doing that question with me. Let's move on to what we have for today. Oh, and if you needed this part, you needed a calculator for that, the YouTube video is up, so you can look about how to do that with your home internet instead of, if you don't have a calculator there to use, the YouTube video is up for how to use your internet for that. Okay, on to what we have for today. Our learning target today is that I know what the inverse trig ratios are, and the success criteria is that you can use the inverse trig ratios to solve right triangles. So that is what we will be doing today, solving right triangles using inverse trig functions. Now I know you might be thinking, Mrs. Dodge, what is an inverse trig ratio? And I am so glad you asked. So you will write this down. You will pause the video and write this down. This is the most important thing that you take away from today. Everything else you should already know by now. And if you don't, go back and watch those videos before watching this one. These are the inverse trigonometric ratios. So basically it's this part. It's this part that you want to pay attention to. And I think this does a good job of saying it too. Normally, so my normal tangent function, you give it some degrees. Yeah, that's an ugly 26. You give it some number of degrees, and it will give you, oh gosh, a ratio. It'll give you a ratio of A to B. Whatever A to B is, I don't know. I have no idea what the tangent of 26 degrees is. So normally, you give it a degree, it gives you a ratio. Now, what we're doing for the inverse tangent inverse, that's what the little, the expression tan to the -1 is read as the inverse of tangent. So that's what the little, that's what the little -1 is up here. Right, what the -1 is that is how we denote the inverse. So now how the inverse works is I'm going to give it a ratio. Tangent inverse will take a ratio, and it will spit out the angle. So before, here, let's use colors. This, oh, hey, what I wanted. This, why aren't you using my... There we go. This works really well for finding side length, when we want to find side lengths. But what if I wanted to find an angle? Well, then that's where this guy comes into play, because now you can find angles. So if I want to find side lengths, I'm using that boy, and if I want to find angles, I need to use this boy. So, yes, hopefully you have all of that written down. Inverse tangent, inverse sine, inverse cosine. It is, yeah. Don't worry about it. Don't worry about it. We're going to do examples. It will make sense. It is the normal trig ratios, but just we're going to undo them as well. Okay, so the very first thing we're going to do is we are going to find angle measures using inverses. So I am told that the tangent of A is equal to 3/4, is equal to 0.75. All I have to do is figure out what angle gives us that ratio. So tangent of what? What does A need to be for the tangent of A to be equal to 0.75? Well, there happens to be a nice button on your calculator for this. And it's like, remember when we had x squared equals 100? To get rid of the square, we took the square root, because that's what gets rid of the square. and then we get x equals 10. It's the same thing. When I have tangent of A equals 0.75, and I want to get rid of tangent, well, the opposite of tangent is tangent inverse. So just like I took the square root of both sides here and it canceled out, here I'm going to take the tangent inverse of both sides, and then that'll cancel out the tangents on this side, and I'm just going to get A is equal to tangent inverse of 0.75. So it's the same thing. I do the opposite here to get rid of the square. I'm doing the opposite of tangent to get rid of the tangent. Okay. So now that you kind of know the theory behind it, let's clean our plate and do it on some real, on the real problem. So, in fact, let's rewrite these so we have more space. Tangent of A equals 0.75. Sine of B equals 0.87. And cosine of C equals 0.15. Okay, we'll start with the first one. To undo tangent, whoa! To undo tangent, we need to take the tangent inverse of both sides. Tangent inverse. And luckily, there's a handy-dandy button on your calculator for this, where the tangent normally is. Oh, you can't see it. Where the tangent normally is, you just hit second, you hit the green button up in the top, you hit second, and then tangent, and it'll do the tangent inverse for you. Another YouTube video is coming today about how to use inverses on the internet. I didn't show you that in the previous video because I didn't want to confuse you since you didn't know what inverses were yet. So be on the lookout for that YouTube video later today. So if I take tangent inverse of 0.75, it tells me, I don't know if you can see that. Oh, we are green screened. Oh, there you go. Tangent inverse of 0.75 is 36.86. So now, remember these cancel each other out, and I just get that A is approximately nearest tenth of a degree. That's important. 36.9 degrees. There you go. And I suppose to be technical, we should say the measure of angle A. So let's say that the measure of angle A. Beautiful. Beautiful. So I hope that you've guessed by now we're gonna do the exact same thing with part B, only we're gonna take sine inverse, because that's what undoes sine, is we're gonna do sine inverse of this side and sine inverse of this side. Those sine inverses cancel each other out, and we get that B is roughly the sine inverse of 0.87 is kinda barely 60.45. Can't find the right lighting for that. That's all right. 60.5 because we're to the nearest tenth. And remember that this is the measure of angle B we're finding. Awesome, awesome, awesome. Okay, one more. And this time, what do you think we're gonna do? What do you think we're gonna do? I think we're gonna take the cosine inverse of both sides. Those are going to cancel each other out, and we are going to get C is approximately, what is that? Cosine inverse of 0.5. Oh, 81. 81.4. 81.4 degrees, and that is the measure of angle C. Awesome. Awesome, awesome. So if you want to undo tangent, use tangent inverse. If you want to undo sine, use sine inverse. If you want to undo cosine, use cosine inverse. And that's basically all of the new information today. Now we're just going to use this example we just did. We're going to use this inverse to solve right triangles. Okay, so, oh, look at that. We can check and make sure we were right, and we were. Fantastic. All right. You don't need to write this down. We just need to read it and understand it. So what this says is to solve a right triangle, because what does it mean to solve a triangle, right? We can solve an equation, get x by itself and everything, but to solve a triangle, what does that mean? So this tells you what that means. It means you're finding all unknown side lengths and angle measures. So if you have solved a triangle, you know what every single side length is, and you know what every single angle is. So you should have 6 pieces of information, 3 angles and 3 sides. 6 pieces of information. You can solve a right triangle when you know either of the following: 2 side lengths or 1 side length and 1 angle. So this is actually pretty cool. You only need 2 of those 6 pieces of information in order to completely solve the triangle. So yes, you need 2 things. You either need 2 side lengths or a side length and an angle measure. Can't have 2 angle measures. That doesn't help us find any of the sides. We could find the 3rd angle, but we couldn't find the side. So you need at least 1 side, if not 2, and up to 1 angle measure. Alrighty, so now we are going to do this. We are going to solve right triangles, and I will show you how. Here's our 3rd example for today. It says to solve the right triangle, and we want to round decimal answers to the nearest 10th. Perfect. That's good information for us to have. Okay. There are many ways to do this. There are many, many ways to do this. You do whichever way makes most sense to you. As long as you do sound mathematical logic, I don't care how you do it. And that's for Mrs. Dodge's class. If you have another teacher, do what they say. But for my class, I do not care how you do it, as long as you are doing sound mathematical logic. Okay, so I'm going to do things the easy way, personally. So, first thing I noticed is that I have a right triangle. That is a right angle. And I'm also noticing that I have 2 of the side lengths here, and I don't know what the 3rd is. So, if you remember back to the beginning of chapter 9, we can use the good old Pythagorean theorem for this. We don't need to do any fancy trig. We could if we wanted to, but what's easier for you? Is the trig easier for you, or is the Pythagorean theorem easier for you? Me, personally, I think the Pythagorean theorem is easier to start off with, so that's what I'm going to do. If you like trig better, hey, you could do trig too. Nobody will get mad at you. Okay. Alright, so, doesn't matter which one is A and which one is B. Legs do not matter. But I'm going to take 3 squared plus 2 squared equals c squared, so 9 plus 4 equals c squared, so 13 equals c squared, which means that c is equal to the square root of 13, which does not have a nice form. Square root of 13 is some decimal, so c... Ah, we ran out of space! Oh wait, no we didn't! Ha 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 ha! So c is approximately 3.6. And that's what we'll use. So awesome, look at that! We already have all of our sides. All the sides are done. We just gotta find the angles. And look at that, we already have one of the angles, because it's a right angle. So, all we have to do is find the other 2 angle measures. So let's switch to a different color. And let's look at angle B first. Let's look at B. Okay. So, if I'm looking at B, we know that this is my opposite side. This is my adjacent side, because the hypotenuse is always opposite the right angle. So, let's see, what could I use? What could I use? Oh man, we could use any of our 3 trig functions. We're not just focusing on sine and cosine today. We're not just focusing on tangent. Now the world is our oyster. So, let's see here. I'm gonna have my helpful SOHCAHTOA up here at the top. And I Mrs. Dodge likes to work in whole numbers. I am not, I can work with decimals. I have nothing against decimals. There's a time and place for decimals. But right now, if I can, I prefer to work with whole numbers, with integers. So I am going to work with my opposite and my adjacent over here, because that's 2 and 3. Nice whole numbers. I don't want to deal with that 3.6 down there. Doesn't sound fun right now. So opposite and adjacent, that means opposite, adjacent, that means I'm going to use tangent. So if I take tangent of B, I will get opposite over adjacent. Beautiful. The diagram's getting too messy here. All right, and to undo this, let's go back to a color that we... To undo this, remember we are going to take the tangent inverse of both sides. And now, if I take tangent inverse of 2/3, I get that the measure of angle B is approximately 33.7 degrees. Look at that. Look at that. Not so bad. Awesome. Awesome, awesome. Okay. You know what we could do now? Oh my goodness, we could... Okay. Ooh. Oh, Mrs. Dodge getting excited. Okay. Another color, purple. I need A, yeah? I've found everything except for A. I have, look, that's 3, that's 2, that's 90, that's 33.7, and that is 3.6. I found everything except for angle A. Now, we could do this, and we could say, oh, this is the opposite, and this is the adjacent, and we can do all of those things. Or, how many degrees are inside of a triangle? Yeah, there's 180 degrees inside of a triangle. So, if I know well, hang on. So I know that the measure of angle A, and the measure of angle B, and the measure of angle C needs to be 180 degrees. I know that. That's the triangle sum theorem. We learned that back in chapter 5. We learned that a while ago. So I don't know what the measure of angle A is, but I do know that B is 33.7 degrees, and C is 90 degrees. So let's see, I'm just gonna write A to keep it simple. So this is A plus 90 plus 33.7 is 123.7 equals 180. If I just subtract 123.7, I am going to get that the measure of angle A is equal to 56.3 degrees. So we can just use the triangle sum theorem. We can just add the 90 and the 33.7 together and minus it from 180. And we can do it that way instead of doing trig. If you like the trig, nothing against trig. Totally can use trig if you want to. But like Mrs. Dodge said, she likes to do things the easy way. And in her mind, this is what is easiest. So if you like this, do this. Next example we do, I can do more trig for you. So now let's double check. We have we have A, measure of angle A, measure of angle B, and the measure of angle C was given. That was our 90-degree angle. And then let's check our sides. We have side A, we have side B, and we have side C. So we have our 6 pieces of information. We know all of the sides. We know all of the angles. So this triangle, it has been solved. Completely solved. Wonderful. Okay, and we could check our answer. Look at that. 3.6, 33.7, 56.3. Beautiful. Beautiful. All right, our next example that we move on to. So notice that in this one, we started out with 2 side lengths. To begin, we had 2 side lengths. In this example, we are starting with 1 side length and 1 angle. So we're going to have to do things a little bit differently this time. No, let's stick with purple. I like purple. Okay. So first things first, I can figure out what G is. Right? 180 degrees in a triangle, 25, 90. I can easily figure out what G is. So let's do that. 25 plus 90 is 115. And 180 minus 115 is 65. So, G is 65 degrees. Beautiful. Awesome. Haha. We already have all of our angles. Nice and easy. Now all we have to do is find 2. We need to find this side and this side. So, which one you want to find first? It don't matter. You want to look at G or you want to look at H. Does not matter. So, let's get a different color here. Let's do G. I want to look at G. Okay, so I can't use the Pythagorean theorem because I only have one side. Pythagorean theorem, if I'm going to solve with it, I need 2 of the sides. So, I'm going to have to use my trig. If this is my angle, that means, let's see, this is my hypotenuse, always, because it's opposite the 90-degree angle. This is opposite angle H, and this is adjacent to angle H. Oh, and we're doing nearest 10th. Almost didn't see that. Good, good, good. Okay, so if we want to look at G, we're going to need to use the adjacent side. And the hypotenuse is the only other side that we have. So we have to use the hypotenuse because it's 13. We know it's 13. We don't know what the opposite is. So we won't worry about the opposite. Okay, so let's see. If I'm using the adjacent and the hypotenuse. Adjacent. Let me write my helpful SOHCAHTOA. Adjacent and the hypotenuse. Oh, look at that. Adjacent and the hypotenuse. So I'm going to use cosine. Wonderful. So cosine of 25 degrees is equal to G, the adjacent, over 13, the hypotenuse. Okay, so next I'm just solving for G. So let's get rid of the 13 from underneath. And now all we have to do is 13 times cosine of 25 degrees. And I get roughly 11.8 is equal to G. Approximately. Okay, fantastic. We know what G is. Now we could use the Pythagorean theorem to find H, if we wanted to. I told you I was going to show you some more trig, so I'll do trig instead, but that's okay. So now if I'm still looking, I'm still going to look at angle H. I could switch to look at angle G, but I am going to keep looking at angle H. Now I have opposite and the hypotenuse. Opposite hypotenuse. Let's see. Opposite hypotenuse. Cool, so we're going to use sine this time around. So sine of 25 degrees is equal to opposite H over the hypotenuse, which is 13. And different color now. To get rid of the 13, I'm going to multiply by it on both sides. And 13 times sine of 25 degrees is approximately 5.5. Ta-da! So now we have 1, 2, 3. 1, 2, 3 sides. Fantastic. So we have all of our sides. And look at that. We have 1, 2, 3, all of our angles. So because we have all of our sides and all of our angles, this triangle is solved. Fantastic. Fantastic. All right, I do believe we should check our answers. All right, 11.8, 5.5, and 65. Perfect, perfect, perfect. So we were right. Example 5. This is extra. This is an extra example. You will not need it for your homework, but will there be bonus questions? There might be bonus questions. We'll have to see. We will have to see. So, solving a real-life problem. Your school is building a raked stage. For you theater nerds out there, you know that that means a stage with a tiny bit of a slope to it, so that it's easier for the audience to see when you're back and when you're upstage and when you're downstage. So the stage will be 30 feet long from front to back, with a total rise of 2 feet. You want the rake, or the angle of elevation, to be to be 5 degrees or less for safety. Is the raked stage within your desired range? So if the angle of elevation were more than 5 degrees, it's going to be a little bit trickier to walk up and down. So if you're walking backwards, you could stumble and trip because you're not used to going up a slope. Your mind thinks it's going to be flat. So we need to see, is this within our desired range? Well, let's redraw this triangle so that it's easier for us to see. Okay, so this is x degrees. We don't know what it is, but we know it's x. This is 30 feet. This is 2 feet. And it's very important that we have this right angle here. If we don't have that right angle, we can't use any of this trig. Remember, to use this trig, we need to have a right angle. So if you don't have right angles, don't even think about using the sine, the SOHCAHTOA, if you don't got right angles. Okay, let's switch colors. We haven't used green enough. All right, so if this is the angle I'm looking at, if x is the angle I'm looking at, the hypotenuse is always opposite that right angle there. Opposite is always opposite of the angle, and adjacent is whatever we got left over. So, which one am I going to need to use? Let's see, I have the opposite, and I have the hypotenuse. So let's see. SOHCAHTOA. Which one am I going to use? Opposite and hypotenuse. Okay. So sine. Sine is going to be the way to go. Beautiful. Let's switch back here. So I know that sine of x degrees. We don't know what x is. That's what we are trying to figure out. Is x less than 5? Equal to 5 or less. But I do know that the sine of x is equal to the opposite over the hypotenuse. Beautiful. Now, to undo this, remember, to get rid of the sine, I need to use sine inverse. I'll use that on both sides. That's going to cancel out these sines, and I'm going to get that x is approximately, I don't know, what is sine inverse of 2 divided by 30? Is approximately 3.8 degrees. So we still haven't answered the question. We know that that's the degree, that is the angle of elevation of this stage, but is it within our desired range? Is it 5 degrees or less for safety? Is 3.8 less than 5? Yes. Yes, it is. So, the answer to the question is yes. The angle of our stage is within the desired range. Smiley face. So that is our final answer there, and we'll We'll put a box around it. Beautiful. Okay, all right. And we can check to make sure that we were right. Yep, inverse sine ratio, 3.8. Yes, it is within our desired range. Fantastic. That is everything I have for you today. So, if you have questions, you know what to do. Mrs. Dodge streams live on YouTube every weekday from 12 to 2, unless her internet is going crazy, like it did yesterday. I apologize for that if you were trying to get on the stream, but we got on eventually. So, every weekday from 12 to 2 p.m. Yeah. Yes, indeed. Okay. You can also email me or comment in the Google Classroom, comment on this YouTube video. I get notifications anytime someone comes. Oh. You could also comment directly on the video to ask questions. All right. Your homework is these questions. So these first 6 are exactly like the first example we did. You're just finding what does D need to be in order for that to be. If tangent of D is 28, what is angle D? And the next 6 questions are completely solving the right triangle. Completely solving it. All 3 angles, all 3 sides. And are there are there bonus questions? Oh, no bonus questions today. If you really want some bonus questions, check out the video coming out today about how to navigate the Big Ideas curriculum online. You can see how to find the book, how to find the questions, the homework questions in the book, and then you can do your own bonus questions if you really wanted some. But the last thing I have for you today is your launch. Your launch is from Winston Churchill. It says, "Success is not final. Failure is not fatal. It is the courage to continue that counts." So let's unpack that. There's a lot there. Success is not final. Once you succeed at something, doesn't mean that you're good to go. You have succeeded, you're done, everything is great. That success, it's like if you worked really hard to get the world record at something. You have succeeded in getting the world record, but is that final? Somebody could take that world record from you, and then it's not final. Or that skill that you had, you can lose that skill, and then, like, say you, I don't know, headbutt 20 watermelons, because I think that was on America's Got Talent or something once upon a time. But if you can't maintain that skill, is that really? I mean, you have the world record, so is that success? I don't know. Something that you get to decide for yourself. Next, failure is not fatal. So what that means is if you fail at something, you're not going to die. It's fine. Failing is human. Everybody fails at something. Heck, we all failed at breathing when we first came out of the womb. That's why you hear about doctors slapping babies. It's so that they start to cry, and they take that to start crying. They have to take that big breath. So if you got slapped by your doctor when you were born, well, slapped. Okay, you know what I mean. We're not beating up babies. We will never do that ever. But you get what I mean. That we have failed at a lot of things, even breathing, when we first were born. So failure's okay, and you're not going to die from it. It's the courage to continue that counts. So whether you succeed or fail, it doesn't matter if you succeed or fail. What really matters is if you have the courage to continue. You have the courage to continue succeeding, to continue helping others through your success. And if you fail, do you have the courage to continue to try again and again? Or the courage to say, this isn't really what I want. Change paths, change goals. So, whether you win or succeed, keep trying. That is the launch for today. Thanks for tuning into the lesson. I am glad that you were here, and have a wonderful rest of your Wednesday. Bye!